Hi, I'm Dr. God King. Today I'm going to talk about the infinite multiplication table. Our mantra for the infinite multiplication table is don't memorize, derive. Basically, this means that the multiplication table should not be learned by rote memorization. Instead, it should be derived. And in Salon Mathematics, which is our approach to doing magical calculations such as in the multiplication table, we cover three mathematical patterns. The first one is times table addition, which we have covered in a previous video. In the last video, we covered hip-hop multiplication, and today we are covering zigzag multiplication. Zigzag multiplication is our description of long multiplication, but we have got a unique approach to doing long multiplication, which we call zigzag multiplication. Short multiplication, for short multiplication, we use a method known as hip-hop multiplication, which we shall go over slightly here, but we had covered it in another video. I would also like to note that this is not about multiplication in theory. It is more than that. Using the approach of zigzag multiplication allows you to unleash your inner genius, innovator, and polymath. That means that you can think in ways that genius, innovators, and polymaths think. And this is a quote that I shall present. If the universe is infinite, why do we limit ourselves to so few possibilities? This quote was presented by an 8-year-old who happens to be my daughter, and she is also a fan of Salon mathematics, and in particular hip-hop multiplication and zigzag multiplication. This fall, she goes to Stanford University, where she will be majoring in symbolic systems, and hopefully she will introduce Salon mathematics, including patterns such as hip-hop multiplication and zigzag multiplication, to her friends as well as her lecturers. But how do you do long multiplication problems like a mathematician? Well, let's look at an example. On this board, we see a simple example of a 12 times 13 problem. And this is a long multiplication problem. So how do you do this like a mathematician? When I was doing my literature search, there were many methods of doing long multiplication. And we see here, this is the Singapore method of doing long multiplication, and it involves 1, 2, 3, 4, 5 lines. This is how we used to do long multiplication when we were in elementary school. It has 1, 2, 3 lines after setting up the problem. This is cross multiplication, and this is the area model multiplication method, which involves a grid, and you have to fill like 1, 2, 3, 4 boxes, and then you add each row, and then you have a final sum. Although they all give the same answers, some involve more steps than others, and these methods do not appear magical. However, I came across a method which appeared magical and was using lines to do multiplication. That approach is called Vedic Math, and it represents numbers using sticks or lines. For example, 12 is represented as 1 and 1, 2. So this is the tens, and these are the units. And the 13, you draw another line here. For 1 and the 3, you represent these 3 lines. And then where these lines intersect, you identify these dots, and then you form an arc, which I usually use to identify the different clusters. So there are 3 clusters. This is one of the extreme clusters, and this is the middle cluster. So in this cluster, there is only one intersection. Here in the middle, you have 3 dots there and 2, so that gives you 5. And here you have 6 dots. So you count them: 1, 3 plus 2, 5, and 6, and this gives you your answer, 156. I found this method very magical when I discovered it, but I wanted to find out how it worked. So what I did was to explore the orientations of these numbers, and I finally orientated the lines horizontally and vertically, and then I put the numbers there, like 1 for 1 line and 3 for 3 lines, and this 1 for 1 line and 2 for 2 lines. When I did the same clustering, I observed that these dots were the same as when you multiplied 3 by 1 gives you 3, 3 by 2 gives you 6, 1 by 1 gives you 1, and 1 by 2 gives you 2. So I saw that the methods were the same, and these were products of these numbers. So I had the idea that you can actually represent the same figure like as I have done here. So instead of focusing on the extreme clusters, I just isolate this one here. And then I tried to develop a simple way in which I could remember how to multiply these numbers. And I came up with this Z pattern. So this circle signifies that you are beginning, and the block means that you are ending. So you go like so, and you have 1, you add 3 plus 2, 5, and then you end up with 6. So that's how I came to this Z pattern, and we end up with the zigzag name. There are many zigzag patterns which you can use depending on where you begin. So if your first 2 numbers begin here, like you have, say, you have an example of like 5 and 2. If they begin here, this is the pattern that you would use. Or like 15 and 2, so it's the intersection of 1 and 2. So this is where they intersect. So this is the pattern that you would use, and then you go up and end up with that. So this gives you all the variations that you can have for a 2 by 2 multiplication. In this case, we are using 13 by 13. So there are 5 steps that you follow when you are doing zigzag multiplication. The first step is that you obtain the long multiplication, which in this case is given to us as 13 times 13. Step 2 means you draw the grid to accommodate the numbers. So if you have 2 digits here, you will draw 3 blocks, and if you have another 2 digits, so you draw 3 blocks. So you have 3 by 3 grid. And then you write for this first number 13 times 13, and then you look at the products. 3 times 1 gives you 3, 3 times 3 gives you 9. So it's just like part of a multiplication table. After you have written that, you take note of where the 2 first digits intersect. So it's at the 1, so it means that you are using this Z pattern. So you begin with 1, and then you go up. 3 plus 3 is 6, and then 9. So that gives you 169. So this is the zigzag method, and you can apply it to different numbers. But this one, 15 times 21, after you have drawn your 3 by 3 grid, 5 times 2 is 10, 5 times 1 is 5, 1 times 2 is 2, 1 times 1 is 1. And then you encircle these numbers and you begin here. Since you have 1 and 2, so this is your starting point. So you go 2, but then when you come to this point, it's 10 plus 1, so that's 11. So you write down the 1 and add another one here. So your initial 2 plus 1 gives you 3. And then you come across, and then that gives you 1. So you can do problems like these if your zigzag grid is already set up. You can do sight calculation. You can just look at the grid and say 2, okay, and then you pick. Since this will give you 11, so this one will begin with 3, 1, 5. So that's how you do. And this is another case, but it's a case of a short multiplication, but you're using a long number. So this method actually covers short multiplication as well. So if you are doing 8 times 3, 4, 5, 0, you can have a 2 by 5 grid, and then 8 times 3 is 24. And then you do hip-hop multiplication, which means that you add 24 and 3, 27, and then 2 and 4, 6, and then 0 and 0 give you 0, and then you write down the 0. So that's the answer. This is hip-hop multiplication, which means that it's not only restricted to doing one digit. You can apply hip-hop multiplication to doing 2 or more digits. In this case, depending on how familiar you are with your multiplication table, you can do 12 times 3 is 36, 12 times 2 is 24, and then you add the 36 and 2, that gives you 38, and then you have 4. Or if you know your 32 times table, you can say 32 times 1 is 32, 32 times 2 is 64, 32 plus 6, that gives you 38, and then you have 4. So these are all things that you can do. But I would like to observe that when you are doing Vedic or stick multiplication, as it is called, you are limited when the numbers are very big. It becomes a very cumbersome process. And in Vedic multiplication, you can also do cross multiplication, but the patterns, as I have shown here, are very complex. But if you are using zigzag multiplication, you can do very sophisticated problems, as you can see here. In the case of 102 times 231, you write 102 times 231, and then you put all the things, and then you can do your zigzag. But please note that you are coming to extremes, and then as you add these, you can have numbers or results like 23562. Another example which is interesting and also shows the capability of zigzag multiplication is having something as complex as this: 42867 times 52049, and you can do your zigzag multiplication and have the answer. So this is all what you need to know for zigzag multiplication. There are many magical things that you can do with it, and I hope you enjoy using zigzag multiplication to do long multiplication in a magical manner. Bye and have fun.